Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Aidiel Hamka. My metric number is AN200004 and my supervisor is Dr. Huda bin Abdul Majid. My title project is IoT-based lab timer tracking system with infrared transmitter and infrared receiver for remote control car. So we go to the first chapter in this project, which is chapter 1, introduction. In this chapter, we have 4 parts, which is introduction, problem statement, project objective, and scope of project. For the introduction, RC car racing is a popular activity enjoyed by people of all ages. It involves operating miniature cars using remote controls to stimulate real-life racing scenarios. While it offers excitement and competition, tracking lap time has traditionally been a manual and time-consuming process due to human error. This method also restricts access to real-time data and makes performance analysis challenging. However, advancement in IoT technology presents an opportunity to revolutionize lap timing in RC car racing, making it automated, efficient, and accessible for all. This is the Gantt chart SM1, which is we have 14 weeks and we also have 14 activities among the 14 weeks. So we go to the flowchart for this project. For PSM1, we have 4 phases for this flowchart. First is planning, second is designing, third is pre-testing, and last is documentation. So you can see this is my flowchart that I make in PSM1. We go to the problem statement. The primary issues that have always arisen when using the traditional lap timers for RC are listed in this section. First problem, we have traditional lap timers for RC cars having limitation in accuracy and reliability due to manual triggering and lack of real-time monitoring and remote access. Next problem is most RC traditional lap timers are standalone devices that do not provide real-time monitoring or remote access and cannot stop the data. And last problem is lack of remote access make it difficult for racing car organizers to handle several cars and events at the same time. We go to the project objective. Here are all the objectives that should serve as a roadmap for this project. Objective 1. To develop a transmitter device that can be attached to an RC car to get car identity and transmitting lap timer data wirelessly. Next objective is to develop a receiver device that can be placed at the finish line to receive the car identity and lap timing data from the transmitter device. Last objective is to record and store lap timing data and allow racers to track their progress and compare their lap times. So this slide is show us for project scope. We have 4 scope in this project, and the first one is the project consists of developing and designing the hardware components needed for the lab tracking system, such as the transmitter unit, receiver unit, sensor, and any other hardware components that may be necessary. The second one is the size and weight of the components must be considered in the construction to ensure they can be readily installed on the RC vehicle without affecting its performance. Next, the software required for running the system must be developed and tested and validated under different racing circumstances. And the last one, the lab tracking system will require an easy-to-use user interface that provides competitors with the data they need to better their performance, such as real-time circuit, speeds, loop pace, and other important data. And now we go to the next chapter, which is chapter 2, literature review. For the existing lap timer system, the sensor of the lap timers are struggle to distinguish individual RC cars and may encounter difficulties in assigning accurate lap timers to each car. This can lead to overlapping or missed lap recordings, compromising the overall accuracy of the timing system. Furthermore, The increased complexity of managing multiple cars simultaneously introduced synchronization challenges, making it harder to ensure precise and reliable lap timing results. This limitation can impact the competitiveness of races and hinder accurate performance analysis for racers and organizers alike. Overcoming these challenges is crucial to enhancing the effectiveness and reliability of lap timer system in RC car. We will look the previous project. For previous project 1 is low cost risk lap timer with time tracking interface. Timekeeping has evolved significantly in the world of racing. Initially, recording participants' time held little importance with only the final results being considered. However, in modern sports and racing, accurate timekeeping is crucial for determining the outcome of events. Human observation alone cannot discern the intricacies of swift movement, particularly in fast-paced races. As a result, race timekeeping now involves complex data processing and utilize technologies such as transmitters and sensors. To address this, a timing device will be developed using microcontrollers like Arduino and Raspberry Pi. Along with other electronic components, the device will employ infrared beaming and signal processing to accurately track participants' time. The timing results will be broadcast through a web server, making them accessible to users and viewers. The primary goal of this low-cost timing device is to provide a versatile solution for various racing events. Let's move on to the next previous project, which is Speed Tracker for Die-Cast Car. This study focused on measuring the speed of toy die-cast cars to enhance the enjoyment of playing with them. Both children and the elderly found pleasure in playing with these cars, whether on a track or displayed as a model. As children, we were always curious about how fast our toy cars could go, which inspired this project. They aim to add more excitement to playing with toy cars by comparing their speeds and creating a sense of anticipation. The project utilized infrared sensor to detect the speed of the toy car. The sensor sent the speed data to an Arduino Uno, which has been programmed to measure the time it takes for the car to pass through designated pressure sensor over a specific distance. Using this data, a simple calculation is performed to determine the actual speed, which can be displayed on an LCD screen. This feature enhances the enjoyment of the game and captivates the crowds. We will go to the previous project 3, Lap Counter Monitoring Tool at the Tamiya Strip Race in Mindaka Village Competition IoT-based. By utilizing sensor-based technology, the lap counting device eliminates the need for manual timekeeping, enhancing the accuracy and efficiency of Tamiya car races. The infrared sensor detects the motion of the cars as they pass through designated checkpoints, allowing for automated lap counting. The Arduino development board, integrated with the ESP8266, provides the necessary computational power and connectivity for real-time data processing and communication. The LCD 16x2 display offers a convenient way to visualize the lap times, providing participants and spectators with instant feedback and excitement. The project aims to create a user-friendly device that simplifies the lap counting process and enhances the overall racing experience by accurately capturing lap times and keeping track of lap complete. The device enables fair competition and enables racers to assess their performance. Ultimately, this project contributes to the advancement and enjoyment of Tamiya car racing through the application of IoT technology. We will go to the previous project 4, overspeed detection with the use of an IR sensor. The increasing population and widespread use of cars have led to in-road accidents, often caused by excessive speeding. To address this issue, the project aims to develop a system that can detect and notify risky driving behavior to prevent accidents. The system utilizes infrared sensor placed on the road to measure the time it takes for vehicles to pass between them. By calculating the speed using a distance time relationship formula, The system can identify vehicles traveling at speed over 50 km per hour. When a vehicle exceeds the speed limit, an alarm buzzer is activated and the LED flashes as a warning. The vehicle speed is also displayed on a 16:2 LCD screen for easy monitoring. The key components of the system include an Arduino Uno, two infrared sensors, an LCD display, and a buzzer. By providing real-time speed detection and warning capabilities, this system aims to promote safer driving habits and reduce accidents caused by excessive speeding. And now, we at the last previous project, which is speed limit adherence for a mobile robot. In Malaysia, speed is the leading cause of road accidents, resulting in fatalities and severe injuries. Excessive and inappropriate speed contribute to a significant number of fatal crashes. Driving at a safe speed is crucial for accident prevention and reducing the severity of injuries. This project focused on developing a communication system to regulate and limit the speed of a motor. The objective was to establish a motor speed cut-off using a single communication system between transmitter and receiver. The system application in areas with speed limits, like school zones, can effectively reduce speed on public transport vehicles and minimize speed-related traffic accidents. The concept involved utilizing a mobile robot and a roadside transmitter and receiver operating at frequency of 433 MHz. The project involved phases such as ensuring clear data transmission, determining the speed limit based on transmitted data, and collecting and analyzing data using statistical method. The successful result of the data analysis validated the effectiveness of the project. So now, let we go to the discussion literature review. Based on the literature review, several IoT-based projects related to lap timing, speed detection, and object tracking were analyzed. The first project focused on creating an affordable timing solution using Arduino and Raspberry Pi microcontrollers. It utilized infrared beaming and signal processing to capture timing data and broadcast it through a web server. The second project involved speed detection using infrared sensor, where data was sent to an Arduino Uno for measurement and display on LCD. In Project 3, an infrared sensor was used to automate lap counting in a Tamiya race line, with the data transmitted to a web server for analysis. The fourth project is aimed to detect excessive vehicle speed using infrared sensors, triggering a buzzer and LED warning. Finally, Project 5 incorporates receiver and transmitter using along with an Arduino, LCD, and motor driver to establish wireless communication and motor control. And this project demonstrates the versatility and practicality of the IoT technologies in various applications. And then this is the summary of the chapter 2, which is literature review. The literature review conducted for the IoT-based lap timer tracking system with infrared transmitter and infrared receiver for remote control car. Project highlighted the advantage and disadvantage of previous projects in this domain, the utilization of Arduino microcontrollers, the effectiveness of IR sensor for speed, and the wireless communication capabilities using 433 MHz receiver and transmitter were identified as a notable advantage. However, limitations such as reliance on 9-volt batteries, complex circuitry, and flaws in design were also observed. In summary, the literature review served as valuable validation for our project, guiding us in evaluating previous work, understanding the advantage and limitation, and implementing relevant technologies. By leveraging this knowledge, we strive to create and improve IoT-based lap timer tracking system that overcome the shortcomings of previous projects and provides an enhanced solution for RC car enthusiasts. Now, we will enter the chapter 3, which is methodology, and this is the introduction for methodology. This chapter presents a detailed account of the methodologies, ensuring transparency and reproducibility. It begins with a project flowchart that visualizes the project's progression and workflow. A system block diagram follows, illustrating the project architecture and component interaction. A system flowchart provides a detailed depiction of process and decision points within the system. A project circuit diagram stimulates the electrical aspect of the project. The chapter also includes a comprehensive list of software and hardware components and covers the hardware preparation procedures. The hardware preparation is important to combine all the components that will be used and it will become a product. So this is my project circuit diagram, and at the left side we have the transmitter device or transmitter circuit diagram, and at the right side, which is the black one, is the receiver device or receiver circuit diagram. So this is the flowchart of the transmitter device. It will be powered by the battery and it will start the system. And first, the transmitter will transmit the car identity and looping until all the car identity is transmitted to the receiver. Then we will go to the flowchart receiver device. At the receiver device, it will start with the get the car identity and time from the transmitter, and if it's detect, it will go to the node rate for the formulating calculation of the lap timers, and then after at the node rate it will go to the MySQL through the MQTT cloud broker, and then it's go to the time. If the time is complete 5 minutes, it will go to the end of the system. But if it's not complete for 5 minutes, it will looping to get the car identity time and time. So it will looping until the time is equal to 5 minutes. Now let's look to the block diagram. This is the block diagram of IoT-based lap timer tracking system with IR transmitter and IR receiver for remote control RC cars. So if the power is on, it will go through the Arduino Nano by detecting from the IR, and then it will transmit the data into the ESP32 with the help of IR, and the data will send to the node rate through the MQTT cloud broker, and then it will go to the MySQL for the storing of the data. So this is the hardware that I use to complete and done this project, which is I use the Arduino Nano, ESP32, IR receiver, battery holder, 3-volt lithium CR2032 battery, and IR transmitter. For the software, I use only 5, which is Microsoft Office for write the whole report, MySQL for storing the data, Arduino IDE to programming the system, MQTT as a clock broker, and node rate as a formulating the calculation of the lap timers. So we will go to the chapter 4, which is expected result. In this expected result, the project is expected to build a system that can track the lap times of RC cars. This may involve using sensor or other device to detect when a car passes a certain point on the track and then transmitting the data to the receiver. The project also is expected to use of IoT technology that the project will involve wireless communication between the transmitter and the receiver, possibly using Wi-Fi or Bluetooth. The system may also be designed to be accessible remotely via web-based interface. The project should involve building both a transmitter and receiver to enable communication between the lap timer system and the RC cars. The use of RC cars in the project title suggests that the lap timer system will be designed specifically for use with this type of vehicle and the tracks. In this chapter also, I have prepared the Gantt chart for PSM2, which is for planning at the PSM2. Still, we have 14 weeks, and we also have the activity through the 14 weeks that will be added. And as you can see, there is no yellow color, which is the actual activities that have been done because it in the planning system of Gantt chart. Last, we enter the conclusion for the whole project. The lab timer system project involved the development of a transmitter device that can be attached to RC cars, enabling the wireless transmission of lab timing data. Alongside this, a receiver device is created to capture and process the transmitted data at the finish line. This component forms the foundation of a comprehensive solution for tracking lap times in RC car racing. Furthermore, the project includes a data recording and storage system that allows racers to monitor their progress and compare lap times. This system offers a user-friendly interface accessible remotely, enabling racers to analyze their performance and gain valuable insight. By combining accurate lap time measurement, wireless communication, and data analysis capabilities, the lap timer system enhances the racing experience for RC car enthusiasts, providing them with a powerful tool to improve their skill and foster the competition. That's all for the conclusion. And as you can see, this is the reference that I use in this whole project. Thank you for watching this video presentation, and that's all for my presentation. Hope panel and supervisor satisfied with my presentation and understand well what that I want to explain. Thank you again for spend your time with this video. Thank you.